Hi everyone, in this video I'm going to solve O-Levels Additional Mathematics Paper 1 in a session May-June 2023 Paper 1-1. So let's start with the first question. Question number 1 part A, write the standard form of quadratic equation in the form of vertex where A, B and C are constants to be found. Okay, so first let me take 5 common. That is a coefficient of x square from the first and the second term. So this would be x square minus 14 over 5x and plus 8 is outside, right? Now complete the square inside the bracket. 5 is outside. We have x square minus 14 over 5x. Now we have to take the x coefficient, which is 14 over 5 divided by 2, which is 7 by 5, and take its whole square, which is 49 over 25. Add 49 over 25 and subtract 49 over 25, and plus 8 is outside. Now we have 5. This is x square minus 14 over 5x plus 7 square over 5 square, right? 8 is outside. Minus 5 is going to multiply with 49 over 25, multiply negative 5, which is minus 49 over 5, right? Now let me close the square. We have 5. This is x minus 7 by 5 whole square and negative 49 by 5, and positive 8 is minus 9 by 5, right? So the value of A is 5, B is minus 7 by 5, and C is minus 9 by 5. Now for part B, hence write down the coordinates of the stationary point on the curve. Okay, so for the stationary point, we have to solve the first derivative and put it equals to 0. We can say y prime should be equals to 0, right? What is y prime? In this case, the y prime is 5 times 2 is 10x minus 14, right? We have to put it equals to 0 and solve for x. 10x minus 14 equals to 0. So x is 14 out of 10, or we can say that 2 times 7 is 14, 2 times 5 is 10. This is the x coordinate of the stationary point. Now we have to solve the y coordinate as well. So for y coordinate, we have to substitute the x value into the curve. So 5 times 7 by 5 whole square minus 14 times 7 by 5 plus 8, right? So 7 by 5 square times 5 minus 14 times 7 by 5 and plus 8, which is minus 9 by 5. So y coordinate is minus 9 by 5. So we can write down the coordinates of the stationary points are 7 by 5 and minus 9 by 5, right? Now for part C, on the axis below, sketch the graph of this absolute function stating the coordinates of the points where the graph meets the coordinate axis, right? So first let me solve for the x-intercepts and the y-intercept for this function, right? So we have the function y equals to 5x square minus 14x without taking absolute. Let me solve the x and the y-intercept, right? So when x is equals to 0, y value is 8. The y-intercept is 8, right? And when y equals to 0, we have 5x square minus 14x plus 8. This would be equals to 0. Okay, let me factorize this. We have 5 times 8 is 40, and 4 times 10 is 40, and minus 4 minus 10 is negative 14. 5x square minus 4x minus 10x plus 8 equals to 0. Taking x common, we have 5x minus 4, and taking negative 2 common, 5x minus 4 equals to 0, right? So the two factors are 5x minus 4 and x minus 2. equals to 0. So from here x is equals to 2 and x is equals to 4 by 5. What is 4 by 5? 0.8. So these are the two x-intercept and 8 is the y-intercept, right? So let me draw the coordinates of the point where the graph meets the coordinate axis. Okay. So for both the x-intercepts are positive. Okay, if I can say this is 1, this is 2, 3, 4, 5, 6. And same for y. 1, 2, 3, 4. Y-intercept is 8, x-intercept is 2 and 0.8. Okay. If I can say this point is 1 and this point is 2. This is 2 and this is, if I can say 2, 4, 6, 8. This is 8. Okay. 6, 4 and 2. Okay. Y-intercept is 8. The x-intercepts are 2 and 0.8. Right. And this is absolute function as well. So we can, the two x-intercepts, right, and the y-intercept. So this is a graph for the absolute function. Now for part D, write down the range of values of k for which the equation this equals to k has 4 distinct roots. Okay, so it has 4 distinct roots. If I can say, if you draw the line y equals to 0, at y equals to 0, this is y equals to k. So it has 2 distinct roots, right? So this is a vertex, right? So the vertex is, this is a vertex, the stationary point or the turning points of the curve, which is 7 by 5, 7 by 5 and positive 9 by 5. This is absolute of 5. This is a vertex, right? Okay, so we have to write down the range of values of k when the equation has 4 distinct roots, right? So as you can see, if I draw the straight line at y equals to 0, it has 2 distinct roots at 0 more than 0 0.1, 0 0.2, 0 0.3 till y equals to 9 by 5. At 9 by 5, it has 2 distinct roots. Less than 9 by 5, it has, between 0 to 9 by 5, it has 4 distinct roots, right? So the range of values of k, we can say this is between 0 and 9 by 5. At 0, it has 2 roots, and at 9 by 5, it has 2 roots. So that is why I'm not using the equality. Question number 2, the polynomial p is such that p of x equals to this, where a, b and c are integers. Part A, given that p double prime of 1 by 2 is 32, show that p a equals to 6. Okay, so let me solve for p prime of x, which is equals to 3ax square plus 14x plus b. Now p double prime of x is 3 times 2 is 6ax plus 14. Okay, now using the condition p double prime of 1 by 2 is 32, right? So 6ax is 1 by 2 plus 14, this would be equals to 32, right? 2 times 1 is 2, 2 times 3 is 6, 3a plus 14 equals to 32, right? So from here 3a would be equals to 32, take away 14. So 32 minus 14 is 18. So 3a equals to 18, and a would be equals to 18 by 3 would be 6. So a equals to 6. Part B, given that p of x has a factor 3x minus 4. 3x minus 4 is a factor of the polynomial. It means p of 4 by 3, this would be equals to 0. And the remainder of 7 when divided by x plus 1. It means p of negative 1 would be equals to 7. Find the values of b and c, right? So let me write down the polynomial p of x, which is equals to 6x cube plus 7x square plus bx and plus c. right? Applying the first condition that P of 4 by 3 equals to 0, right? So P of 4 by 3 equals to 0. 6 times 4 by 3 whole cube plus 7 times 4 by 3 whole square plus B times 4 by 3 plus C, this would be equals to 0, right? Okay, now 4 by 3, its cube, and multiply by 6 is 128 over 9, and 4 by 3 square multiply by 7 is 112 over 9 plus 4 by 3b plus c equals to 0. So 128 plus 112 is 240. So this is 240 over 9 plus 4 by 3b plus c equals to 0, right? Okay, so 390 divided by 9 is 80 by 3. 80 over 3 plus 4 by 3b plus c equals to 0, right? Taking 3 as an LCM, so this would be 80 plus 4b plus 3c, this would be equals to 0, my first equation, right? Now using the second condition, let me use here that P of negative 1 equals to 7, right? The second condition is P of minus 1 equals to 7, and make another equation. Okay, so 6 times minus 1 cube plus 7 times minus 1 square plus b times minus 1 plus c equals to 7. So this is negative 6 plus 7 minus b plus 6 equals to 7. So 7 and 7 is cancelled, minus b plus c would be equals to positive 6, or we can say that the c value is 6 plus b, my second equation. Let me substitute the second equation into the first, right? So 80 plus 4 times b plus 3 times of c, c is 6 plus b, this is equals to 0, and let me solve for the b value. 80 plus 4b plus 3 times 6 is 18 plus 3b equals to 0. So 4 plus 3 would be 7b plus 80 plus 18 is 98. 98 equals to 0, right? So what is the b value? B value is negative of 98 divided by 7. 98 by 7 is negative 14. So b is minus 14, right? Now let me solve for c by substituting the value of b in equation number 2. So here the c is 6 plus b is minus 14. 6 minus 14 is negative 8. C equals to minus 8, right? Now part C, write p of x in the form 3x minus 4 into q of x, where q of x is a quadratic factor, right? Let me write down the polynomial p of x first. P of x equals to ax cube, which is 6x cube plus 7x square plus bx, b value is negative 14x plus cc is negative of 8, right? And from part B, we know that 3x minus 4 is the factor, right? So it means at x equals to 4 by 3, the polynomial equals to 0, using the method of synthetic division here. Okay. So x would be equals to 4 by 3. The coefficients of x cube, x square, x, and the constant are 6, 7, minus 14, and minus 8, right? Bring the first term as it is. Now 4 by 3 is multiplying by 6. 4 by 3 times by 6 is 8. Add 8 and 7. 7 plus 8 is 15. Now 15 is multiplying with 4 by 3. This is 20. and 20 subtract 14 is 6. 4 by 3 times by 6, this is 8, and positive 8 negative 8 would be 0, right? Now we can write down p of x as x minus 4 by 3 and 6x square. 6x square, this is the coefficient of x, 15x, and plus 6 is a constant term, right? Now let me take 3 common. So 3 is common. So we have x minus 4 by 3. Okay, and 3 is common, I'm taking from here, which is 2x square plus 5x plus 3. Okay, now let me multiply 3 inside the bracket, which is 3x minus 4 into 2x square plus 5x plus 3, right? This is a quadratic factor. Now for part D, hence write p of x as a product of linear factors with integer coefficients. So we have to factorize this, right? So if I can say 2x square plus 5x plus 3, let me simplify this. 2 times 3 is 6, right? Sorry, this is 2 here, not 3, because 3 times 2 would be 6. So 2 times 2 is 4, 4 times 1 is 4, so 2x square plus 4x plus x plus 2. This would be equals to 2 is common and x is common. So x plus 2 plus 1 is common, x plus 2. So the factors are 2x plus 1 and x plus 2. Right. Now we can write down p of x from part C. We have 3x minus 4 into 2x square plus 5x plus 2, and the factorization is this: 3x minus 4, 2x plus 1, and x plus 2, product of 3 linear factors. Question number 3. The points A and B have coordinates 2, 5 and 10 minus 15 respectively. The point P lies on the perpendicular bisector of line AB. So first we have to find the perpendicular bisector of line AB, and the point P lies on that line. The y coordinate of P is minus 9. Part A, find the x coordinate of P, right? So first let me find the perpendicular bisector of AB. For this we have to find the midpoint of AB, adding the x component, dividing by 2, 2 plus 10 by 2, and adding the y components divided by 2, 5 minus 15 by 2. This would be 2 plus 10 divided by 2, 2 plus 10 divided by 2 is 6. 5 minus 15 divided by 2 is negative 5. This is the midpoint. Now let me find the slope of AB, which is y2 minus y1. y2 minus y1 is negative 15, negative 5 over x2 minus x1. This is minus 15 minus 5 minus 20 divided by 8, which is minus 5 by 2. And from here we can say the slope of perpendicular bisector of AB is negative of reciprocal, which is 2 by 5, right? Now equation of perpendicular bisector of AB is y minus y naught, which is negative 5, equals to m, which is 2 by 5, into x minus x naught, right? So y plus 5 equals to 2 by 5 into x minus 6. All right, this is the equation of perpendicular bisector of AB. Now point P lies on this line. So if y coordinate is negative p, find the x coordinate. If it lies, it satisfies. So y coordinate is negative 9 minus 9 plus 5 equals to 2 by 5 into x minus 6. Let me simplify and solving for x. 5 minus 9 is negative 4. Negative 4 times 5 by 2 equals to x minus 6, right? Times 5 divided by 2 is negative 10. Minus 10 plus 6 equals to x. So plus 6 is negative 4. So negative 4 equals to x. It means the point P has a coordinate x is minus 4 and y is minus 9, right? Now for part B, the point R is the reflection of P in the line AB. Find the coordinates of R. Okay, so if let's say this is my line AB, right? A and B, and this is a point P, right? And we have to find the point R, which is a reflection of P. So the reflection is the mirror image. So we have, let's say the point R is over here and P is over here, and this is the midpoint of the line, right? So we have to just find we have point P, we have the midline, we have to find the point R. So using the midpoint, we can find the other endpoint of the line, and the reflection is basically the perpendicular bisector of this line, right? So we can say the midpoint we have is 6 minus 5. This is equals to adding the x components, dividing by 2. Our x component is x and px component is minus 4, divides 2, and y minus 9 by 2. All right. So from here we can say x minus 4 divided by 2 equals to 6. And x minus 4 equals to 2 times 6 is 12, and x equals to 12 plus 4, so x would be equals to 16, right? Now for y, y minus 9 divided by 2 equals to minus 5, so y minus 9 equals to 2 times 5, negative 10, y equals to minus 10 plus 9, so y equals to negative 1. So we can say the coordinates of point R, x, y, x is 16 and y is negative 1, right? Question number 4. The diagram shows the velocity time graph for a particle traveling in a straight line with velocity v meter per second and at time t seconds. When t equals to 30, the velocity of the particle is v meter per second. The particle travels 800 meters in 45 seconds. 0 to 45 seconds, the total distance traveled is 800 meters, right? Now part A, find the value of v. Okay, so we have given the total distance traveled. Distance traveled in velocity time graph is equals to area under the graph, right? So the distance traveled is 800. This would be equals to the area under the graph. Area of this triangle, this rectangle, this shape is a trapezium and a rectangle. So area of this triangle between 0 to 10 is half. The base is 10 and the height is 10. Plus area of this rectangle, base is 10 and the height is 10. So it's a square. 10 times 10. Plus area of this trapezium, the height is 10, half the sum of parallel side, this side is v and this side is 10, so 10 plus v multiplied by the height, which is 10, plus the area of a triangle, this 30 to 45 is 15, half base is 15 and the height is v, right? Now let me solve for the v value. Okay, so 10 times 10 divided by 2 is 50. This is 800. 50. 10 times 10 is 100. And this would be 10 by 2 is 5. 5 times 10 is 50 plus 5v, right? So 2 times, this is 2 times 1 is 2, 2 times 5 is 10. 5 times 10 is 50, 5 times v is 5v. This would be equals to plus 15v by 2, right? Now further simplification, we have 50 plus 100 plus 50 is 200, so 800 minus 200 is 600. This would be equals to, the v's are 15 by 2 and plus 5, and this is 25 by 2v. So solving for v, we have 600 multiply 2 by 25. 600 times 2 divided by 25 is 48. So 48 is the value of v, right? Now for part B, find the acceleration of the particle when t equals to 35. Acceleration is basically the gradient. So at t equals, this is t equals to 35. So at 35, this is a deceleration. It's going downward. So it is negative, right? Which is a change in y values over change in x values. The y values change are 15 and the x value changes between 0 to v, which is 48. So the acceleration we can say is negative because it is downward. Change in y value is 15 over change in x values. Y value is 48 and x value is 15. So this is 48 over 15, 16 by 5. Negative of 16 by 5 because acceleration is downward at 35. So this is deceleration in negative direction. Question number 5. Do not use a calculator in this question. In this question, all lengths are in centimeters. Part A, you are given that cos 120, sin 120 and tan 120 is given. In the triangle ABC, AB, BC and angle ABC is 120. Find AC, giving your answer in the form of a square root of b, where a and b are integers greater than 1. Right. Let me draw this triangle. Just a rough sketch. Okay, let's say this is a triangle ABC. A, B and C. We have given AB, which is 5 square root of 3 minus 6. We have given BC, which is 5 square root of 3 plus 6. And we have given the angle ABC. This angle is 120 degree. Right. We have to find AC. Okay. So we have the two sides and the angle between them. So let me apply law of cosine here. Law of cosine. Law of cosine says AC square equals to 5 square root of 3 minus 6 AB square plus 5 square root of 3 plus 6 AC square minus 2 times 5 square root of 3 plus 6 into 5 square root of 3 minus 6 into cos of 120 degree. Calculator is not allowed, so let me simplify AC square. Open the square, which is 25 times 3 plus 6 square is 36 minus 2AB. 2 times 5 is 10 and okay, let me write this down. 2 5 square root of 3 into 6 plus 25 times 3 plus 36 plus 2 into 5 square root of 3 into 6 minus 2. This is a plus b and a minus b. So a square minus b square. So a square is 5 square is 25. Square root of 3 square is just 3. Minus 6 square is 36. And cos 120 is given, which is minus 1 by 2. Right. Further simplification, AC square 25 times 3. 3 times 5 is 15 and 3 times 2 is 6, 7. So 75 plus 36 minus 2 times 5 is 10 and 10 times 6 would be 60 square root of 3 plus 75 plus 36 plus the same thing is 60 square root of 3. 2 is cancelled with 2, negative is cancelled with negative, so this is positive 75 minus 36, right? So 36 and minus 36 is cancelled, minus square root 60 square root of 3 plus 60 square root of 3 is cancelled, right? So we are left with 75 plus 75 plus 36 and plus 75. Okay, let me add them up. 75, 75 and 75, and then with 36. 5 plus 5 is 10, 10 plus 5 is 15, 15 plus 5 is 20, and plus 1 is 21. 7 plus 7 is 14, 21, 22, 23, 24, 25, 26, 261. So this is AC square, right? So AC square is equals to 261. Now we have to write down 261 as a square root of b, and a and b should be integers and they are greater than 1, right? So we have AC equals to square root of 261. Okay, so let me solve the square root of 261. Okay, 261 is if I can do with 3 times table, 3 times we can say 3 times 7 is 21, 3 times 8 is 24, 3 times 9 is 27, 3 times 8 is 24, 25, 26. 2 3 times 7 is 21, right? Now again with 3 times table, we can say 3 times 2 is 6, and 3 times 9 is 27, and 29 is a prime number, right? So we can say AC is square root of 3 times 29. So we have 3 in pair, so we can say square root of 3 square times 29, right? Or we can say 3 square root of 29 is the answer. A and B, A square root of B and A and B are integers and they are greater than 1. Now for part B, you are given that cos 30, sin 30 and tan 30 in the triangle PQR, PQ and the angle PQR is 30 degree. Given that the area of this triangle is this much, find QR, giving your answer in the form of C plus D square root of 5, where C and D are integers. Again, let me draw the triangle to understand the situation. Okay, so this is a triangle P, Q and R, right? We have given PQ, which is 3 plus 2 square root of 5, and we have given angle PQR, which is 30 degree, right? We have to find QR, right? And we have given the area, right? So using the information of area of a triangle has a formula which is half AB sine C, right? So area we have given, which is 2 plus 5 square root of 5 divided by 4. This would be equals to half the product of two sides, which is PQ and QR, 3 plus 2 square root of 5 into QR and sine of 30, which is given 1 by 2, right? Okay, let me solve for QR. 2 plus 5 square root of 5 divided by 4 equals to 1 by 2. 3 plus 2 square root of 5 into QR into 1 by 2. Sine 30 degrees 1 by 2, right? So this becomes 1 by 4. 2 plus 5 square root of 5 by 4 equals to 3 plus 2 square root of 5 divided by 4 into QR. So 4 is cancelled with 4, right? So now QR is 2 plus 5 square root of 5 divides 3 plus 2 square root of 5. This is the QR. Now we have to rationalize it by the reciprocal of denominator. 3 minus 2 square root of 5 divides 3 minus 2 square root of 5, multiplying and dividing. This is QR, right? Okay, so in the numerator 2 times 3 would be 6 minus 4 square root of 5 plus 2 times 3, 2 times 2. 5 times 3 is 15. 15 square root of 5 minus 5 times 2 is 10. Square root of 5 times square root of 5 is just 5. This whole divides with a plus b into a minus b is a square minus b square. So 3 square is 9 minus 2 square is 4 and square root of 5 square is just 5. This is QR, right? Now we have 6 and 5 times 10 times 5 is 50. Now 6 take away 50 is 44, negative 44, right? And from 15 if we subtract 4 we have 11, so plus 11 square root of 5, and in the denominator we have 9 minus 4 times 5 is 20. This would be equals to QR. 20 minus 9 is 11, right? So 11 square root of 5 minus 44 divided by 11, this is QR, right? We have to divide both terms by 11, so this is square root of 5 minus 4, and this would be equals to QR, right? So we can say, sorry, this is negative 11, so minus square root of 5 and plus 4, or we can say QR is equals to 4 plus negative square root of 5 in the form of C plus D square root of 5. C is 4 and D is negative 1. Both are integers. Question number 6, part A, show that the left hand side equals to right hand side, right? Okay, so let me open. Cot is cos over sine. Cos theta, I'm solving from left hand side, over sine theta. Tan is sine theta over cos theta, right? And secant is 1 over cos theta. 1 over cos theta. Okay, now let me take LCM. This is cos square theta plus sine square theta divided by cos theta sine theta. And whole divided by 1 over cos theta. Right. Now we can cancel this cos with this, and we are left with cos square theta plus sine square theta is just 1 over sine theta, and 1 over sine theta is reciprocal of sine is cosecant theta. This is equals to my right hand side. Proved. Now for part B, hence solve the equation. Okay, so we have an equation. If I can compare it with the part A, we have cot theta plus tan theta over secant theta whole square equals to 2. So theta is replaced with 5 by 3, right? So this is cosecant theta. So this would be cosecant theta 5 by 3 whole square equals to 2, right? Now let me simplify this. Cosecant is 1 over sine. 1 over sine square 5 by 3 equals to 2, right? Now let me cross multiply. 1 by 2 would be equals to sine square of 5 by 3, right? Further simplification, we have to do square root on both sides. So 1 over square root of 2 with a plus minus sign equals to sine 5 by 3, right? Now we have two cases. Case 1 is with positive and case 2 is with negative. Okay, let me solve both of them. So the one first is sine 5 by 3 equals to 1 over square root of 2, and the second is sine 5 by 3 is negative 1 over square root of 2, Okay, and we have given the domain should be in between minus 540 degree to plus 540 degree. It is in degrees, right? Now let me check sign is negative and positive in which quadrant. Okay, using the CAS rule. Okay, so in the first we have just theta, and here we have 180 minus theta, here we have 180 plus theta, and here we have 360 minus theta, right? Okay, so we can say 5 by 3 would be equals to sine inverse of 1 over square root of 2. Let me solve in degrees. Okay, my calculator is in radians. Let me convert them into degrees first, and then you can do sine inverse 1 divided square root of 2 is 45 degrees. So 5 by 3 equals to 45 degrees, right? Okay, now sine is positive in which quadrant? You can see sine is positive in first and second quadrant. So first quadrant is 45, second quadrant is 180 minus 45, which is 135, right? Now for the next we have 5 by 3 is sine inverse of negative 1 over square root of 2. Sine inverse of 1 over square root of 2 is again 45. Sine is negative in third and fourth quadrant. So we can say 5 by 3 in the third quadrant is 180 plus 45, which is 225. And 360 minus 45, which is 315. Right. Okay, now we have 5 by 3. We have 3 revolutions. So we have to add 180 and subtract 180 in all these values, right? So let me add 180, adding 180 and subtracting 180, right? In 45, add 180, which is 225. 135, add 180, which is 315. 180 minus 45 is 135. 180 minus 135 is 45. Adding 180 again and subtracting 180 degree here. 225 plus 180 is 405. And we have 315, add 180, this is 495, right? 225 minus 180, sorry, 180, 180 subtract 225 is minus 45, and 180 subtract 315 is minus 135, right? These are all the values of these 6 values, and these 6 values total are 12 values are for 5 by 3. Let me solve for 5. So the 5 values are, we have to multiply by 3, right? 3 times 45 is 135. 3 times 135 is 405, right? And we have to pick the values that are between minus 540 to plus 540, right? So these two values lies between the range, right? Now 3 times 225, this is more than the given range. 315 times 3, this is also more. 135 times 3, this is 405 is already written. And 3 times 45, this is already written, 135, right? Now the next is 3 times 225, it's 600 something, it's more. 315 times 3, 900, it's more. 405 times 3, it's more. 495 times 3, it's more. And 3 times minus 45 is minus 135 is in the range, minus 135 degrees. And minus 135 times 3 minus 405 degrees is also in the given range. So these values belongs to minus 540 degree, it's less than 5 is less than 540 degree, right? Question number 7, part A. A team of 8 people is to be chosen from the group of 15 people. Number 1, find the number of different teams that can be chosen, right? So out of 15 you have to make a combination of 8, 15 C8. 15C8 is 6,435. Right. Now for part B, find the number of different teams that can be chosen if the group of 15 people contains a family of 4 who must be kept together. Right. Family of 4. So we can say with family and without family. We have two cases. Okay. So with family, their total are 15 and the members are 4. 15 minus 4 is 11. So 11C4, right? So total are 15. Now we have a family of member of 4. So from 15 we have to subtract 4, which is 11. So total are 11 out of 4. So 11C4 is 330, right? Now let's work on without family. So without families, again the total is 11. 11C. Now from the total is 4. If we add 4, which makes 8, right? 11C8. Without families, 11C8 is 165. Now the total is 330 plus 165 is 495. Okay. Now for part B, given that this would be equals to this, find the value of n. So we have to remember the formula of permutation. NPR equals to n factorial over n minus r factorial. Using this formula, and let me open the permutation. Okay, so this is n plus 9 into n factorial over n minus 10 factorial. This would be equals to n square plus 243 into n minus 1 factorial over n minus 1 minus 9 factorial. Okay, so this is n plus 9 times n factorial over n minus 10 factorial. N factorial, n into n minus 1 factorial. Let me open this. N square plus 243 into n minus 1 factorial over n minus 10 factorial. Let me cancel the like terms. N minus 1 factorial and n minus 10 factorial. Right. So we are left with n into n plus 9. And here we have n square plus 243. Right. Now let me simplify. N square plus 9n minus n square plus 2 minus 243 equals to 0. Right. Cancel positive n square and negative n square. So we have 9n minus 243 equals to 0. Right. So we have 9n equals to 243, and here n would be equals to 243 over 9. 243 divided by 9, which is 27. So here n equals to 27. Question number 8. A curve has equation y equals to this. Part A show that dy by dx is this, where a and b are integers to be found. Okay. Let me differentiate the function y dy by dx by applying a quotient rule, right? So we can say denominator function square, which is 2x plus 1 whole square, 2x plus 1, derivative of the numerator function. So derivative is the power rule we have to apply here, which is 1 by 3 into 2x 3x minus 4, and the derivative of 3x minus 4 is 3, minus numerator function is 3x minus 4, its power is 1 by 3, derivative of denominator is 2. Right. So here 3 is cancelled with this 3. So we are left with sorry, it's power rule, power the base function and power minus 1. So 1 by 3 minus 1 is minus 2 by 3. 2x plus 1, 3x minus 4, its power is minus 2 by 3, and minus 2 into 3x minus 4, its power is 1 by 3, and this whole thing is divided by 2x plus 1 whole square. Right, now let me shift this power into the denominator, which is 2x plus 1 divides 3x minus 4, power is 2 by 3, minus 2 into 3x minus 4, power is 1 by 3. Okay, and this whole is divisible by 2x plus 1 whole square. Right, now let me take an LCM. So we have 2x plus 1 minus 2. Okay, so 1 by 2 minus, okay, 1 by 3, adding the power 2 by 3 is just 1. So 3x minus 4. And this whole divides by 2x plus 1 whole square is as it is, this and this term. 3x minus 4, power is 2 by 3. So as you can see, 2x plus 1 whole square, 3x minus 4 power 2 by 3. Right, let me simplify the numerator. So this is 2x plus 1 minus 2 times 3 would be 6x, plus 2 times 4 is 8. This whole divides 2x plus 1 whole square into 3x minus 4 power 2 by 3. Right, so now we have minus 4x plus 9 divides 2x plus 1 whole square into 3x minus 4 power 2 by 3. So ax plus b, a is minus 4 and b is equals to 9, and these two should be in integers. Right, now for part B, find the coordinates of the stationary point on the curve. So the coordinates of the stationary points are basically when the derivative equals to 0. Stationary point can be formed by putting y prime equals to 0. So this is y prime. So let me put this equals to 0. So the denominator is multiplying with 0 by cross multiplication is 0. So we have 4x minus 4x plus 9 equals to 0. And from here we have x equals to 9 by 4. So 9 divides 4 is 2.25. This is the x coordinate of the stationary point. To get the y coordinate, we have to substitute the x value into the function y. Right, so we have y equals to 3 into 2.25 minus 4 whole power is 1 by 3 divides 2 into 2.25 plus 1. So what is y? Okay, 3 times 2.25 minus 4, and its power is 1 by 3. Or if we can take it's 11 by 4, 2.27, 2.75 whole power 1 by 3, and the denominator is 2 times 2.25 and plus 1 is 5.5. Now let me simplify. 2.75, its power is 1 by 3, and divide 5.5, 0.255 if I round it, 0.255. Now we can say the coordinates of the stationary points. The xy coordinates are x is 2.25 and the y is 0.255. Right. Question number 9, part A. The first three terms of an arithmetic progression are ln q power 4, ln q power 7, where q is a positive constant. Okay. The sum of n terms of this progression, Sn, is equals to this much. Find the value of n. So we have given Sn. So for arithmetic progression, Sn has a formula which is n by 2 into 2a plus n minus 1 into d. Right. Using this formula, Sn is given, which is 4845 ln q. Right. This is equals to n by 2 times the first term, which is ln q, plus n minus 1 into d. D is the common difference. So d equals to second term minus first term, ln q4 minus ln q. Right. So this would be equals to 4 ln q minus ln q. So this is 3 ln q. 4 minus 1 is 3 into 3 ln q. Okay. 4845 ln q equals to 9 by 2 ln q plus 3n ln q minus 3 ln q, multiplying with n minus 1, right? Further simplification, we have 4845 ln q equals to n by 2 is outside, which is 3n ln q, and 2 minus 3 is minus ln q. Right. Now let me open the bracket. 4845 ln q equals to 3 n square divided by 2. So 3, this is n square by 2, yes, ln q minus n by 2 ln q. Let me take ln q common and cancel with the left hand side. 4845 ln q, this would be equals to 3n square minus n ln q by 2. Okay, now let's cancel ln q with ln q, and doing a cross multiplication, times by 2. 4845 times by 2 is 9690. So 3n square minus n and negative of 9690 would be equals to 0. Right. Now let me solve for n. This is a quadratic equation in n, so we have to solve by using a quadratic formula. Let's say 3n square minus n minus 9690 equals to 0. Right. So the quadratic formula is n equals to negative of b plus minus square root b square minus 4ac divides 2 times of a. So the a value is 3, b is minus 1, and c is minus 9690. All right. Let me substitute everything into the formula. So we have n would be equals to negative of b, which is 1, plus minus square root b square minus 1 square is 1, minus 4ac, minus 4 times the a value times the c value. Okay, which is plus 116280 divides 2 times 3, which is 6. So add 1 and take its square root, 341. N equals to 1 plus minus 341 divided by 6. So we have two values of n. From here, n would be equals to 1 plus 341 divided by 6, which is 57, and 1 minus 341 divided by 6 is minus 56.7. So n should be positive because n is a number of terms, right? So we have to take this. because number of terms never be negative. Now for part B, the first three terms of a geometric progression are 1, 2, and 3, where p is a positive integer. Find the nth term of this progression, giving your answer in the form of this. Nth term of geometric progression is un equals to u1 a r power n minus 1, right? So the nth term is un, which is equals to the first term p power 3x. R is the common ratio. R is second term p power x divides the first term p power 3x. So this would be p power x into p power minus 3x. Base is the same, adding the power p power x minus 3x, right? Or we can say that p power x is common, 1 minus 3 is p power minus 2x. Okay, so the common ratio is p power minus 2x, its power is n minus 1, right? Okay, now let me convert it into this form. Right, p power 3x into p power multiplication is minus 2xn plus 2x. Bases are same, adding the powers. So p power 3x minus 2xn plus 2x, right? So here we have p power 5x minus 2xn. Let me take x common. So p power 5 minus 2n into x. So this is in the form of p power a plus b and x. A is 5, b is negative 2. Now for part C, the first three terms of a different geometric progression are these. For theta is between 0 to pi by 3. This is a range. Find the set of values of theta for which this progression has sum to infinity, right? So we have s infinity, which is equals to the first term over 1 minus the common ratio when absolute of r is less than 1, right? Or we can say that minus 1 is less than r is less than 1. So it has, this geometric progression has a sum to infinity when the common ratio is between minus 1 to plus 1. Let me solve for r first. The second term is 16 over 9 cos 4 3 theta over the first term is 4 by 3 cos square 3 theta, right? So this cos square and this is cancelled with cos square. We are just left with cos square, and we have 16 by 9 divides 4 by 3. 4 by 3 is the answer. 4 by 3 cos square 3 theta is the common ratio, right? Now let me put into this inequality. Minus 1 is less than 4 by 3 cos square 3 theta is less than 1, right? So first we have to do minus 3 by 4 is less than cos square 3 theta is less than 3 by 4, right? And then taking a square root on both sides, so minus square root of 3 by 2 is less than cos 3 theta is less than square root of 3 by 2, right? Now we have to do cos inverse of negative square root of 3 by 2 is less than 3 theta is less than cos inverse of square root of 3 by 2. This is the range we have given is in radians, it's pi, so we have to solve in radians. Okay, let me use the cast rule here and check cos is positive and negative in which quadrant. Okay, so we have C A S T, this is theta, this is pi minus theta, pi plus theta, 2 pi minus theta, right? Now cos is negative in second and fourth quadrant. So let me solve for the positive case, right? So cos in radians first. Okay, this is in radians. Now cos inverse of square root of 3 divided by 2 is pi by 6, right? So this value is pi by 6, and cos is positive in first and in fourth quadrant. So 2 pi minus pi by 6. 2 pi minus pi by 6 is 11 pi by 6, right? So this is 3 theta. Okay, cos is negative in second and third quadrant. So cos inverse of square root of 3 by 2 is again pi by 6. So we can do pi minus pi by 6, which is 5 pi by 6, and pi plus pi by 6 is 7 pi by 6. Okay, now we have to dividing by 3 throughout the equations. Okay, 5 pi over 18, 7 pi over 18 is less than theta is less than pi over 18 is less than 11 pi over 18. Okay, now which values satisfy? Sorry, not less than, it's a comma here. The values of theta is between 0 to pi by 3, right? So which values are satisfying in the given range? 0 to pi by 3 is, if I can say, 1 by 3 is 0 0.3. So 5 by 18 is more, it's 0 less than, yeah, it is in the range 0 0.27. 7 over 18 is more than 0 0.3, right? So 1 over 18 is, this is in the range. Yes, 11 over 18 is, this is more, right? So this is not in the range, this is not in the range. So the solution is, the values of theta is between 5 pi by 18 is less than theta is less than pi by 18, right? But we have to arrange it, because 5 by 18 is 0 0.27 and 1 over 18 is 0 0.05, right? So we can say pi over 18 is less than theta is less than 5 pi over 18. This is the correct inequality, because this is more, this value is higher. So now higher value is after the theta. Question number 10, it is given that y equals to this, find dy by dx, the first derivative. So dy by dx, y prime is basically the product rule. So 3x plus 1 whole square, the derivative of ln of 3x plus 1, which is 1 over 3x plus 1, into the derivative of 3x plus 1 is 3, plus ln of 3x plus 1 into the derivative is power rule, power the base function 2 minus 1, and the derivative of base function is 3, right? Now we have to cancel 3x plus 1 with 3x plus 1. So we have 3 into 3x plus 1 plus 6 into 3x plus 1 into ln of 3x plus 1, right? Now let me take 3 and 3x plus 1 common, right? So we have 1 here, plus we have 2 3x plus 1 into ln of 3x plus 1, right? Now for part B, hence find the integration of this function, right? So from part A, we have the derivative of this function would be equals to this. Let me rewrite. We have given that d by dx of 3x plus 1 whole square ln of 3x plus 1, this is equals to 3 into 3x plus 1 plus 6 into 3x plus 1 into ln of 3x plus 1, right? So if I do the integration on both sides, let me integrate both sides. That would be integration and the derivative d by dx of 3x plus 1 whole square ln of 3x plus 1. This would be equals to 3 integration of 3x plus 1 dx plus 6 is outside, integration of 3x plus 1 ln of 3x plus 1 dx, right? Integration 3x plus 1 ln of 3x plus 1 dx, this we have to solve, right? Okay, so here we know that derivative and integration is cancelled, so we are left with 3x plus 1 whole square ln of 3x plus 1. This is equals to 3 integration of 3, x is x square by 2 and x is just 1 is just x, plus 6 and integration of this function 3x plus 1 into ln of 3x plus 1 dx, right? Let me shift this term on the other side. So that is, we can say the integration of 3 in x plus 1 into ln of 3x plus 1 dx dividing by 6, 6 and 6, right? This would be equals to, okay, 3x plus 1 whole square divided by 6 ln of 3x plus 1, right? So I did the two steps here, divided by 6, all the three terms are dividing by 6, this term is 1, this is divisible, this is dividing by 6, and this is 3 times 1 is 3, 3 times 2 is 6, 3 by 6 is 1 by 2, so minus 1 by 2 into 3x square by 2 plus x plus some constant of integration, right? So the simplified answer is 1 by 6 into 3x plus 1 whole square ln of 3x plus 1 minus 3x square by 4 minus x by 2 plus some constant of integration, right? So that was the last question of our paper. If you have any queries, please let me know in a comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.